Sorry, go ahead.
This is Sheila Wilkerson, and I'm here with Alexis Manning and Melissa Marriott, and we are going to walk through the 7 steps to writing a function and discuss some of the functions in our role-playing game called Pemberley. So the first step in writing a function is to identify to define the problem, and we get that information from our end user story. So here we have step 1, define the problem, and the task is what the function will do, and in this case we're going to calculate new weight when an item is added to inventory and ensure the weight does not exceed the limit. Then we need to have the information to perform the function, so those are our inputs right here, and these first 2 are from the user, and this one is called from pass-through from memory. Then we have the output to be returned, the current new weight in this case, and the validation rules that need to be enforced. So in this instance, the weight cannot exceed 20 pounds, and the items that can be taken by the user at a time is between 0 and 9. So the next step is to create a test matrix, and that is to prove the function works properly. So here's our test matrix, and we make up input values to satisfy the conditions that are being tested. So we have a valid test, some invalid tests, and some boundaries that correspond to our validation rules.
All right, step number 3 is outline the solution. The outline for a function is an algorithm that will be written in pseudocode. Pseudocode is basically a simplified mock version of a language without using the syntax. And I just want to emphasize here that the right steps need to be placed in the right order. So when you're doing your outline, the outline of the function needs to be in the order of the operation that will be used in your code. Step 4 is test the algorithm. So in this step, you are going to pretend that you are the computer, and you're going to execute each case in the test matrix. So the first part of that is identifying the variables used in the program that will contain values in the memory. Second part is creating a table, like you see here at the bottom, representing the value of each variable in memory for each test case. The third thing that you will do is enter input values in the test matrix for the current test case into the corresponding variables in memory. And the last thing that you will do for this testing the algorithm is stepping through each of the instructions in the outline and then updating the variables in the memory as you go. And if the results match, you are good to go.
All right, for steps 5 through 7, you need to first take the algorithm. There's a copy of the algorithm here. And the goal for step 5 is to translate that algorithm into the language that you're going to be using, in this case, JavaScript. So once you put it inside the development environment, it's not going to recognize the code because it's not Java, it's pseudocode. So you should go through line by line and translate it. So in Java, for example, in Java you need a public or a private there, and you need to declare what kind of return type it's going to be. And you also need to tell what types of parameters are going into it. So for this instance, double, and integer. So you go through each line of the pseudocode and translate it into the code language that you are trying to write in. And for that example, this is our code right here after we're done with that. After you're done translating each line, the next step number 6, is to create test cases for it. This is our test case file here. I'm not going to go into that too much because we'll be talking about that as we go through each of our functions. Once you have created each test case, and it comes out successful, then the last step is to commit and then to push to the repository. Those are steps 1 through 7 of creating a function.
Okay, so next I'm going to explain our calculate add inventory weight. So that is right here on line 17 in our inventory control. And as Melissa said, we have these variables here, and current weight, and new item inventory are all passed by value because they're native types that are, oh, nope, they're all just passed through by value. And then the program on line 18 is going to verify that the item is between 0 and 9. If not, it will return a -1 and give the user an error code. If it's otherwise, it will keep going and it will run the calculation, and if it meets this test right here to be greater than 20, it will return an error. If it's okay, then it will return the new weight to the user. And so here we have a test of that in our test case here. So this is test case number 1. On line 54, you can see that the current weight is 54. Now remember, they can have as much as 20 pounds. So on line 55, the item is 2 pounds. They are requesting 2 of them. Down here, the instance is created, and we expect the result to be 19. And there's one more test case down here we'll look at. This is test case number 4, which has to do with our boundaries. And so on line 113, the current weight is 16. The weight of the item requested is 8 pounds, and they're requesting 2. So because 2 times 8 is going to put them over the limit of 20 pounds, we expect the result to be an error message and tell them that they can't carry this much weight.
Okay, so I will be discussing the calc remove inventory weight, which is found in our inventory control. And this function is calculating the weight of the bag when items have been removed from the bag. And on line 29, this is the function that will get the new weight, which will be returned by a value, passing by value the parameters of new weight, current weight, and new item. And on line, let's see, 30, so what this is saying is if the new item quantity is less than 0, or if the new item quantity is greater than 9, then the program will return a -2. And on line 34, the new weight is being assigned to whatever the current weight minus the new weight times the new quantity number is. And on line 35, so if this new weight has been assigned is less than 0, then the program will return a -1 because it's invalid. Otherwise, as you see on line 38, it will just return the new weight. So here's a control test that we have made, and this is case number 1. So on line 285, you can see that we have entered 8 is our current weight, 2 is our new weight, and 3 as our new item quantity. On line 291, we've created our instance, and on 293, we're expecting our result to be 2. And then lastly, on 296, we are just calling the function through the parameters of current weight, and new item quantity so that we can run the test.
Okay, our third function that requires a calculation is the check can get function. and it's going to take the integer quantity limit, current quantity, and new quantity, and these are all being passed by value. And the purpose of this function is to make sure that they don't have more than 9 at a time. So the first if statement makes sure that it's not less than 0 or more than 9, otherwise it will return false. And then here's the calculation. So the current quantity is how many they're carrying, like if they're carrying 8 apples and they want to get 2 apples, then if this is 9 and this is 8 and this is 2, then it would be less than 0 and return a false. Otherwise, if this is 8 and this is 1, 9 take away 9 is 0. So it would return a true, saying that this item can get. And then the test case for this, right here, test 1 is the quantity is not, the limit is 9. They currently have 7. They're trying to get 1 more. The test should return a true because that 7 plus 1 is less than 9. And then the other cases we have are errors. For instance, if the limit is 9, they have 1, they're trying to take 10, the expected result is false. So now we've talked about test cases for all 3 of our functions that require calculation. The next step is to test the file. I already have the test up, so I'll show you that. And each of the calc remove inventory weight, the check can get, and the calc add inventory weight, they all came back as positive, so 100% passed. Well, now that I've talked about the check can get, I want to go ahead and move into talking about the other function that I created, and that function is the take single item function. This function will move a single item from the location that the player's in, if it's takeable, and put it into the inventory. But first it has to pass a few checks. So it's going to take item to take as a parameter. This is being passed by reference because it's not a native type. The quantity to take is an integer. It's being passed by value. And the inventory is also being passed by reference because it's referring to an object. The next thing that this function does is it calls the calc add inventory weight, the first of our 3 calculation functions. It's taking the current weight that the inventory is, the item to take's weight. So if the apple weighs 5 pounds, that's what would go in there, and the quantity to take. And this is always going to be 1 for this take single item function. It's going to put the potential weight in this variable potential weight here. And then it's going to run through some if-else statements. The first if statement is it checks to see that the item or the apple or whatever is being taken is takeable. If it's not takeable, which that exclamation point means not takeable, then it will either return a message saying you can't get that at this time, or it will return whatever's in the item's take message. So in our game, for instance, the note can't be taken because the hamster is guarding it. So it will say the hamster is guarding this, so you can't take it. Well, if it passes that test, I mean, it is takeable, so it skips this. It will go to the potential weight, and then we'll see if it returns a -2. If it does, it will say you are trying to carry too much. Well, if it doesn't qualify for this if statement, and it doesn't qualify for this else if statement, then it's going to go ahead and move the item into the inventory. And it's going to set the inventory's weight to the inventory weight that it was before plus the potential weight. So this number right here. And then it's going to return a message saying you take the apple or whatever is being taken.
Okay, next I'm going to talk about the function, one of the functions that I worked on, and it's the look at item function, which is executed when the user goes to the look menu and makes the selection to look at an item here, meaning in the location where the player is. So that function is here in our item control. And here it is, the look at item, and it's going to return a string. The player selection is passed by value. The player and the local item array are all passed by reference because they are objects. So the first thing that you're seeing on line 45 is the system going through an array of items and making a list of all the items that are in the same location as the player. And then on line 46, we've realized through this iteration that it makes better sense to have the instance created here in the item control, and we plan to move that and simplify this. On line 47, the system goes through the item array in the inventory control, which will be item control later, and it makes a list of all the items in the local item array and only returns the items located in the same location as the player. So it's comparing the player's location with the items in that location and returns that to the system, and then to the user, excuse me. And then if the item is located in the location of the player, it will return a description of that item. So it will say something like, the lamp is located here, and we'll give a description of that lamp. Otherwise, if it's not in the same location as the player, it will return this statement on line 42, that item is not available here, and will return and allow the user to continue to make a selection until they select X to leave the menu.
All right, so now I'll be talking about the function that I worked on, which is move player function found in the Explore menu view. And this function calls the parameters of the player by reference. And just a note here, the player is being passed so that its scope can even exist within the realm of this function. So on line 110, we are assigning which direction you want to go by prompt with this string to the viewer. And on line 111, this string variable, player selection, we're just assigning that so that it can be used in the do function found later down. Lines 112 through 117, this is just a loop that is going to keep looping until the player hits X for cancel. So line 113, this passes the prompt by value to get input to verify if the player selection is valid. Line 114, this is our instance of map control. And line 15, we are just calling the function here, and we're doing so by parameter of player selection and player. And just a note here that player selection is passing by value and player is still passing by reference. So jumping over to our map control, line 16 is calling the player navigate from the Explore menu. And line 17, this is our variable current room, and current room is just saying that this is wherever the player currently is. Line 18, this is another variable next room that we will be using later throughout this function. And 19 is where our switch starts. And 19 through line 38, this just all depends on what the player has input. And based on what they have put into the program, we are then going to set the next room. If it doesn't match, then the default shown on line 38 will be not sure where you are going. Now we jump down to line 44. If the next room doesn't have a direction in it, it will return, you cannot go that direction. otherwise is found in on line 49, it will say you move to the, and it'll be whatever the room that the player has selected.
Okay, finally we want to talk really quick about the lifespan and scope of a variable. An example of that can be found in the Explore menu view in the variable called string prompt. So right here you see string prompt on line 137. It can be used throughout. Its scope is everywhere that's between this bracket and this bracket. It can be used anywhere in here. As you see on line 148, prompt is used here. Is how many do you want to take? Well, once it leaves, this prompt leaves this section right here, its lifespan is over. It's whatever is this prompt right here. Okay, that is our presentation, and we hope that you have enjoyed watching it.